so if we're looking at now the multiplication division of complex number, which is on page 48 of your notes. Okay, so the two results you need to know. So when you express things in a complex number in modulus argument form, okay, two separate complex numbers in modulus argument form, and we want to multiply those two numbers, okay? So we want to multiply z1 and z2, so z1 can be x1 plus y1 I, and z2 can be x2 plus y2 of I, okay? We multiply them together, okay, we can set them up into modulus argument form, and what we can do is actually multiply the modulus together and add the arguments together, okay, when we're multiplying. When we're dividing, we divide the modulus of both z1 and z2, okay, so that's r1 and r2, and we do a subtraction of the argument of z1, sorry, the subtraction of the argument of z2 from the argument of z1. Okay, so if z1 is r1 cos theta 1 plus I sine theta 1. Okay, so we're just going to get to that point where we're seeing how it works. Okay, and z2 is r2 cos of theta 2 plus I sine theta 2. And remembering that's also cis theta, okay, cis is cos and sine. Part in the brackets there, okay, the shorthand to say that, okay, but I've written all of that because we need to use some trig identity to be able to derive the result. Alright, so z1, z2, okay, it's going to be this times this, isn't it? Alright, so what I'm going to do is bring the modulus of both of them out the front, okay, so that's why we've got r1, r2. When we multiply, we can multiply in any order we want. Okay, so cos theta 1 plus I sine theta 1 and cos theta 2 plus I sine theta 2. Okay, so we're going to expand that right out using our FOIL. R1, R2, so we've got cos theta 1, cos theta 2. I sine, cos. I cos theta 1 sine theta 2. I sine theta 1 cos of theta 2 plus I squared sine theta 1 sine theta 2. From there. Okay, so remembering that I squared is negative 1, so that's going to become a takeaway. Okay, so if I group the real and imaginary parts together, okay, so I've got that is my real part, and that will also become my real part there, okay, once I evaluate I squared. Right, then these two are your imaginary parts, okay, so group both the real and imaginary. Okay, so R1, R2, so we have cos theta 1, cos theta 2, take away sine theta 1, sine theta 2. Where have I seen that before? Cos theta 1, cos theta 2, take away sine theta 1, sine theta 2. Yeah. Cos of theta 1 plus theta 2. And cos theta 1 sine theta 2 plus sine theta 1 cos theta 2. I've seen that one before as well, haven't I? What's that? I sine of theta 1 plus theta 2. Okay, so it equals R1, R2 cis of theta 1 plus theta 2. Okay, so when we're multiplying two complex numbers, we represent them in modulus argument form. Okay, and the multiplication of two complex numbers is the multiplication of the modulus and the addition of the argument in your cis. Okay, so Z1 over Z2. So R1 cos theta 1 plus I sine theta 1 all over R2 cos theta 2 plus I sine theta 2. Okay, so I want to derive the result that we've already got the division of the modulus, but now we need to derive that it's going to be a subtraction of the arguments. Suggestion? By what? Times cos theta 2 take away I sine of theta 2 over cos theta 2 take away I sine theta 2. Okay, so we've already got the R1 over R2 business there. Okay, so cos theta 1 cos theta 2 take away I cos theta 1 sine theta 2 plus I sine theta 1 cos theta 2 take away I squared sine theta 1 sine theta 2. Using your FOIL in there. Okay, so we've got the different two squares on the bottom, so it'll be cos squared of theta 2, take away sine squared. Okay, however we're going to have a negative 1 for the result of I squared. Okay, so when we expand it out and simplify, we're going to get cos squared of theta 2 plus sine squared of theta 2. So we just made the denominator real by multiplying by the conjugate. Okay, and we've got the same result, don't we? Well, just about. So we've got the real part here and here. So we've got negative I squared, which is the negative 1. So we've got cos theta 1 cos theta 2 plus sine theta 1 sine theta 2. Okay, which is what? Cos of theta 1 take away theta 2. When we've got the addition, opposite for cos. Good. Yep, so we've got the denominator of 1 here as well. Okay, and then plus or minus? Plus, okay. I sine of theta 1 take away theta 2. Yep, because when you factorise the negative out, you have a negative between those two brackets. Through there. And that's your result. So equal R1 over R2 cis of theta 1 take away theta 2. Okay, so you need to know the result, and obviously it will always be beneficial to understand how it's derived. Okay, simplify, plot the result on Argand diagram. Okay, so it's already represented in modulus argument form for you. Okay, so we're multiplying because the brackets are next to each other. Okay, so this is going to be 2 times 5, multiply the modulus, and you're going to add the arguments when you multiply. Cis of 5 pi on 12 plus 5 pi on 6. Okay, so it equals 10 cis of 5 pi and 4. Okay, now what is pi in degrees? 80. Okay, so what's pi on 4? 180 divided by 4, I meant. Yep. The pi on 4. And then 45 times 5. Okay, so that's going to help me to plot it, obviously. Okay, so 225 going to be halfway between 180 and 270, isn't it? Because of the pi on 4. And then 10 is the modulus. Okay, so what that means is in the 225, so we're way around the third quadrant, and 45 degrees between these two axes. Okay, so that's where the number goes, the complex number. Okay, so going back to the question, so we've got 5 times 180 divided by 12. Okay, so what's 180 divided by 12? Oh, half that. 15. 15 times 5 is? 75. Okay, let's call this part Z1 and Z2. So 5 pi on 12 is 75. Pi on 6 is 30 times 5. Okay, so we've got the angles of point radius 2 from the origin and an angle of 75 degrees. Okay, so 75 degrees and the radius of 2, so that's the approximate location of Z1. okay, with its radius. And then Z2 was 5 cis of 5 pi on 6, so 5, a radius of 5 and an angle of 150. Okay, so it's going to be something out there for Z2. What you've done is you've multiplied 2 and 5 to get the new radius out here of 10. And you've added 75 to 150 and you've gotten your 225. Okay, so that's the representation of that on your diagram. Okay, so this will be Z1, Z2. Right, part B, if Z equals 1 plus root 3i over, all over 1 plus I, part 1, express Z in the form x plus yi, where x and y are real. Okay, so what do I need to do? So 1 plus root 3i over 1 plus I multiplied by its conjugate. Okay, so we can get the denominator as a real number with no imaginary part, so that we can represent the complex number, the division of a complex number as a specific real and a specific imaginary part. Right, so FOIL at the top.
That's simplified, but it doesn't look simplified and I don't like it.
Yeah, I see your point. Okay, expressing 1 plus 3 root 3i and 1 plus I in modular argument form, show that Z equals that. Root 2 cis of pi on 12. Okay, so for 1 plus root 3i, so we need to represent both those in modulus argument form. Okay, so how do we do it? How do we express a complex number in multiple argument form? How do we find the modulus? One blank. I don't think they've noticed yet.
The shirt.
Yeah, have you?
It's really nice. I really like it. It's cool.
You can react to it all like.
It's a cool shirt.
Thank you. Okay, so we need to calculate the modulus. Z1, we'll call it. Square root of x squared plus y squared. So 1 squared plus root 3 or squared. I've only done like 6 examples of these on Tuesday. Use 2.
There's so many different maths.
Yep, well, we gotta keep on top of it, don't we? Okay, and the argument is, how do we calculate it?
There's a sine and a cos involved.
Are you sure?
No, that's the
Is it
important.
A plus
No.
A something?
No.
No, it's Swivl. No.
This is a problem. I hear that.
Yeah, it
Testing
was
for
silent clause involved, but you
Testing
totally
for
went off on a tangent on that. That's for sure. Tan inverse of the imaginary part over the real part. Okay, you need to know these. Okay, you need to be getting cracking on your task and keeping on top of things. Okay, there is so much we're doing in theory. You need to keep on top of it. Okay. All right. So, which quadrant is this complex number in? The first, because both the real and imaginary part are positive. Okay, so that means we just need to treat it as the basic angle in the first quadrant. So what's tan inverse of root 3? Tan what angle? What angle
60,
makes root 3?
60, yeah, 60.
Which is what in radian?
Pi
Okay. What's the other one? 1 plus I. Alright, so 1 plus I. So modulus, we'll call it Z2. Square root of 2. That should be trivial there. And the argument is going tan inverse of 1 over 1.
45.
Yep, which is what in radian?
4.
And we're in the first quadrant again. Okay, so we just need to consider the basic angle. Okay, so Z is going to be the modulus argument form of Z1. So 2 cis of pi over 3 all over the modulus argument form of the number on the bottom of your fraction. Root 2 cis of pi on 4. Okay, we are doing division now. So when I do a division, I do the division of the modulus and a subtraction of the argument. Did I leave room? Nope. Was I clever and did I plan ahead? Thank you. Alright. Equal 2 over root 2 cis of pi on 3, take away pi on 4. The third minus a quarter is?
It's pi over 12.
So it's, yeah, pi over 12.
So 2 on root 2 cis of pi on 12. Do we have the result we needed? Nope.
We have to
So I'm going to get that bit.
times it by
times.
root 2.
Yeah.
Rationalise the denominator. So 2 root 2 over 2, and that's what gets me what I need. Okay. We're good? So we now need to hence find the exact values of cos of pi on 12 and sine of pi on 12.
We want to expand it back into modulus the argument form and then do something with that. Yes, no, so is that okay?
No, can use that.
Yeah, put that one away. Put it that much.
Where'd I go from here?
Six. One, four.
Okay.
Let's go backwards.
Then backwards.
We just got from that, you don't want to go back.
Like the radian in degrees.
So,
Like the radian degrees.
Wait, so what's the question?
find the exact values of cos pi on 12 and sine of pi on 12.
What did you calculate?
The exact value.
That'll work, won't it? Here we go. 0.9.
Is that an exact value, is it?
0.9998995.
No.
Expand? No.
Spin what?
Root 2 into those. Should we do that or not?
2 pi.
I don't know. It's scary.
Yeah, I'm having a mind blank because you guys are confusing me.
Anything we feel.
Alright, so we went back and proved from the first part, x plus yi in there. And that's the result, isn't it? Okay, and then this, if we went through this and expressed this in modulus argument form, okay, we'll get that. Okay, because it's essentially what we did here, isn't it? Okay, so it's going to equal this bit. Right, root 2 of 1 plus root 3 over 2 plus root 3 take away 1, sorry, of I over 2. Now we need to match it. So therefore, because pi on 12 is going to be the real part,
1 plus 3 over root 2.
now it is actually 2 root 2, I'm now trying to remember how that works. something about the two out the front, but it works. And I'm trying to remember a couple of days ago I did it now. I'll come back to it.